Yes, hello everyone. So today we will discuss some important NEET questions. You know that the NEET exam is near. So let us discuss these important questions. The question number 1 is the compound C7H8 undergoes the following reactions. Now C7H8 3 times chlorination in the presence of heat gives you A. Then this is your electrophilic substitution reaction, bromination in the presence of a Lewis acid gives you B, and B in the presence of zinc and HCl, this is your reducing agent, gives you C. So let us discuss this question. So C7H8 is basically, when the carbon is more than 6, always look for a benzene ring. This is your 6,7H8. So this is your toluene. Now toluene on 3 times chlorination in the presence of heat. Now this will result in the benzylic substitution. You know this results in the benzylic substitution. So these 3H will be substituted by chlorine like this, CCl3. Now this will undergo electrophilic substitution reaction, that is bromination. Now please note that CS3 group is your electron donating group, but when the 3H are substituted by chlorine, now this becomes CCl3 group, and this is your deactivating group, and this is your now this has become electron withdrawing. So you know that this CCl group is your meta director. So bromination in the presence of some Lewis acid, it gives you, for example, FeBr3, it gives you the meta product like this. And in the last step, this is zinc in the presence of HCl. It is basically used for the reduction of alkyl halides to alkanes. So the CCl3 will get converted to CS3, and this bromine will remain like this. So basically from toluene you end up getting meta-bromo-toluene. And this is also a good reaction because you know that CS3 is your electron donating group, it is your ortho para director. So if you would have performed bromination with toluene, you would have got ortho bromotoluene and para bromotoluene, but by this conversion you get meta bromotoluene as a product. So basically in this reaction meta bromotoluene is the answer. I hope you understood this question. Let us discuss the next question. Next question is, a given nitrogen compound containing aromatic compound A reacts with SN, tin and HCl. This is again for the reduction. Followed by HNO2 to give an unstable compound B. B on treatment with phenol forms a beautiful colored compound C with the molecular formula C12H10N2O. And the structure of the compound compound A is. Now if you see carefully, this HNO2 is basically used for the diazotization reaction. Yes, so a given nitrogen containing compound A reacts with SnHCl. You know that this is a reducing agent. We use it for the reduction of nitro compound to the amine. So basically if I start with this nitrobenzene in the presence of tin HCl or FeHCl, I end up getting aniline. This is your aromatic amine, aniline. Now aniline on reaction with HNO2, you know it results in the formation of a diazonium salt. HNO2 You know, this is a combination sodium nitrite and HCl, and the reaction condition is 0 degree to 5 degrees Celsius, right? So I end up getting diazonium salt like this. This is your benzene diazonium salt. Now benzene diazonium salt is B. This is your unstable compound. This on reaction with phenol. So this on reaction with phenol, what will happen? You know that this is your azo coupling reaction. I have H over here. This is your azo coupling. Yes, this is your azo coupling reaction. So this H and this Cl will be eliminated in the form of HCl, and what do you get is something of this sort. N double bond N. This is your azo group, and here you get this. So this is your para-hydroxy azobenzene. Para-hydroxy azobenzene, and you know this is your azodie. This is your azodie, and it is orangish color. Yes, orange colored dye. Right. So if you see, then this A. So you are asked about A. So A is nitrobenzene, and this is how we end up getting para-hydroxy azobenzene. I hope you understood this question. Let us move to the next question. Next question is again a series of reactions. Let us discuss these reactions. So in a set of reactions, metabromobenzoic acid gave a product D. Identify the product D. Now look at the first reaction. So first reaction is basically the reaction with thionyl chloride. You know, in the first step I end up getting something like this. This COH will convert to COCl. Yes, acid chloride. This is after the first reaction. Now this on treatment with ammonia, you know, what do I have? I end up getting, this is minus HCl, I end up getting amide. I end up getting amide, CONH2, right? This is a benzamide, and this bromine will remain intact. And the last reaction is important. This is your Hoffman bromamide degradation. Hoffman bromamide degradation. Why degradation? Because I end up getting an amine from amide with one carbon less. So this is degradation. Yes, so what do I have in the last step? This is bromine in the presence of NaOH, Hoffman bromamide reaction. I end up getting something like this. This amide will convert to amine, and this Br will remain like this. So I end up getting C as the answer. I hope this is clear. So again, a good question with a series of reactions, and this is how we end up getting this product. Let us discuss the next question. The next question is again the series of reactions. So we start with phenol. This time we have phenol. Phenol on reaction with zinc dust. Yes, reaction with zinc dust. This is a common reaction. You know that I end up getting benzene. Yes, I end up getting benzene. What do I have next? Next is the reaction with CH3Cl, and in the presence of anhydrous AlCl3 aloes acid. This is your Friedel-Crafts alkylation. Again your electrophilic substitution reaction. What will happen? This will attack on this carbon, this leaves, or you can say that this CH3 plus, this alkyl group is your electrophile here. So this will attack on this electrophile, and what do I have? I have toluene. Now you know that what happens next? Next is this on treatment with alkaline KMnO4. Now please note that no matter how long this chain is, it will get oxidized, it will be converted to the benzoic acid. But please remember, I should have the H over here. This should be the alpha H should be present over here. So I end up getting benzoic acid. Even if it would have been ethyl benzene or propyl benzene, I would have got benzoic acid as the answer. So benzoic acid is a right answer. The Z is your benzoic acid. I hope this is clear. Let us move to the next question. Next question is, in the following sequence of reactions, the end product C is. Okay, so again we have a series of reactions. I start with this, like methyl bromide. This on treatment with KCN. First is simple. This is your simple SN2 reaction, right? Br will be substituted by CN. This I got nitrile. Yes. Now nitrile undergoing hydrolysis. So you know that I get acid from the hydrolysis of the nitrile. So I end up getting acetic acid. And acetic acid, in the last step, it is reacting with lithium aluminium hydride, which is your which is a strong oxidizing agent. And I get CS3 CH2OH as the product. So this C is your ethyl alcohol. Ethyl alcohol. You know that lithium aluminium hydride is a strong reducing agent. This is a strong reducing agent, and it can reduce acid and even acid and esters both to the alcohol. Clear? Let us discuss. So, and also when nothing is written over here, so I will consider a complete hydrolysis only. This is complete hydrolysis. If it would have been partial hydrolysis, I had got CS3CONH2, that is amide. Yes? Alright. Next question. The end product C in the following sequence of reactions is, okay, so I have acetylene. This is your dehydration. This is your basically I have 1% HgSO4, 20% H2SO4. Okay, so this is your hydration of alkyne, acetic hydration of alkyne in the presence of mercuric ion. So what do I have? In the first step, you will have something like this. This is your enol form. You know that this enol form will tautomerize to the keto form, right? This will attack over here and this bond shifts here. So what do I have? I have CS3 and CHO. I'll get acetaldehyde. So this is, if I have acetylene and I perform this hydration, I end up getting aldehyde. Now, any other alkyne will give you, like for example, if it would have been propyne, then you would have got ketone as the product, right? So here I have got acetaldehyde. This is via tautomerism, right? And the aldehyde is reacting with Grignard reagent. So this aldehyde, let me write aldehyde like this. This is your aldehyde. It is reacting with Grignard reagent, methyl magnesium for say halide. This is the methyl magnesium halide. This is this is negative, this is positive for obvious reasons because metals are electropositive. This acts as a nucleophile. It will attack on this electrophilic carbon. This bond goes here. What do I have? And this is followed by hydrolysis. So I will get, after hydrolysis, I will get this as the product. Yes, I will get this as the product. So this is basically your 2-degree alcohol. And you know that acetaldehyde on treatment with Grignard reagent, it gives you 2 degree alcohol. If it would have been formaldehyde, that would have given you the 1 degree alcohol. And in the case of ketones when react with the Grignard reagent, you end up getting the 3 degree alcohol, right? Now the reaction is not complete, it is not yet complete. So in the last step, this secondary alcohol is undergoing oxidation, and you know that secondary alcohol upon oxidation gives you a ketone. So I end up getting acetone as the product. So I end up getting acetone. So acetone is the right answer. This is your ketone. This is the ketone. I hope you understood this question. Let us move to the next one. Identify the major products P, Q and R in the following sequence of reactions. Now again we have a sequence of reactions. Benzene on treatment with propyl chloride in the presence of anhydrous aluminium chloride. This is again your Lewis acid, and this reaction is again Friedel-Crafts alkylation. And in the second step, it is your oxidation. This P upon aerial oxidation followed by acidic hydrolysis gives you Q and R. Alright, so in the first step, I have benzene. Benzene on treatment with this. You know, I'll have this kind of electrophile at the first place, but then I have option, like this is your 1 degree carbocation. I know that I can get 2 degree carbocation if I shift this hydride over here. So if I perform this hydride shift, I would end up getting this carbocation, because you know that this reaction, this carbocation undergoes rearrangement if possible. So it was 1 degree at the first place, and by hydride shift I get 2 degree carbocation, which is obviously more stable. Then this will attack on this particular carbon, and I end up getting isopropyl benzene. This is, instead of propyl benzene, I get isopropyl benzene like this. I get isopropyl benzene, right? Now, this isopropyl benzene is also called cumene. This is also called cumene. This is isopropyl benzene. Now isopropyl benzene upon aerial oxidation followed by the acidic hydrolysis gives phenol, and you know that this is your commercial production of phenol also. Yes, so I get phenol. Cumene hydroperoxide is the intermediate, which upon hydrolysis gives you phenol and acetone, and we get acetone in fair amount. Yes, so we can also call it the preparation of acetone also, right? So this is not, we will not treat it as a byproduct, we get it in fair amount. So so phenol and acetone are the products. So Q and R are phenol and acetone, and P is your isopropyl benzene. So if I see, fourth is the right answer. This is the isopropyl benzene, phenol and acetone. All right, let us move to the next question. So we have already seen it. In a set of reactions, acetic acid yielded a product D. Alright, again a sequence of reactions. So we have acetic acid. In the first reaction, it is treated with thionyl chloride. So you know this A will be your acid chloride, right? So this is what I will have. This is my A, right? Now A upon treatment with benzene, in the presence of anhydrous AlCl3. So if you see carefully, this reaction is basically your Friedel-Crafts acylation, because this acyl group is your electrophile over here. This acyl group is your electrophile over here. So this will attack on this carbon, and what do I have is something like this. C double bond O CH3. Right? So this is your acetophenin. So acetophenin is B. This B is acetophenin. Now this upon treatment with HCN, you know I have the electrophilic carbon, I have the nucleophile which is Cn minus. So this Cn minus will attack on this electrophilic carbon. This bond goes here, which upon hydrolysis will give you, this is what I will get, C, and obviously if I perform the protonation, this is OH. Here I will also get the CH3 is there already, and I get CN. So this is your cyanohydrin. This is your cyanohydrin. Yes, this is, that this is your nucleophilic addition reaction of the carbonyl compounds, and this upon hydrolysis, that CN undergo hydrolysis to form COH, acid group. So what do I have? COH, CH3, and upon hydrolysis this will convert to COOH. So this is my desired product D. So the structure of D is I think the right answer, CCOH, OHCH3. So B is the right answer. Yes, B is the right answer. I hope this is clear. Yes, so this is what I get after this. Now, next question. Next question is, of the following, which is the product formed when cyclohexanone undergoes aldol condensation followed by heating? Now, followed by heating, it makes it aldol condensation, and you know that the product will be alpha beta unsaturated aldehyde or ketone. Though I can easily eliminate the options, but we will also see the mechanism. So this is your cyclohexanone. This is the cyclohexanone. This upon treatment, in the presence of base only. Alright. So this is base. I have this alpha H. Abstract this. I get a carbanion. This carbanion is resonance stabilized. What we call resonance stabilized enolate ion. So what will happen next? The anion that I have, this anion, write it here. Double bond negative. This anion upon aldol reaction will take place. What will happen? This will attack on this electrophilic carbon. This bond goes like this, and upon hydrolysis I end up getting something like this. Double bond O. From here this has formed a bond like this, and this has become O, and upon hydrolysis this will become OH. Now that this is your alpha carbon, this is your beta carbon. At alpha carbon I have H, so there is an elimination of water molecule which is called aldol condensation upon heating, minus H2O, so and I end up getting alpha beta unsaturated ketone like this. I end up getting alpha beta unsaturated ketone like this. So if you see, A is the right answer. Is that clear? So till here, till the formation of the aldol or ketone, it's aldol reaction. After heating, this is called aldol condensation, and you get alpha beta unsaturated compound, alpha beta unsaturated carbonyl compound, unsaturated carbonyl compound. Please know that these reactions are very important, and it will definitely help you in the upcoming NEET exam, right? The last question for the day: which of the following reactions will not result in the formation of carbon-carbon bonds? Alright, we will see all the four reactions one by one. Number one is Reamer-Tiemann reaction. This is the reaction of phenol. I have phenol in the presence of a strong base for say KOH and CHCl3. This combination results in the formation of the electrophile, and this electrophile is dichlorocarbene. Please note that this question has been asked many times. This is frequently being asked in the exam. So this is your this is your dichlorocarbene. So this is the electrophile over here, and the end product is orthosalicylaldehyde, right? Why ortho is the major product? Because we can have the hydrogen bonding over here, intramolecular. So this is orthosalicylaldehyde, and here if you see, it results in the formation of new carbon-carbon bond. So A cannot be the answer. Let us discuss the next, Canizaro's reaction. So if Canizaro, you know, it is the disproportionation reaction where I have, for say, benzaldehyde, which is not having no alpha H is present. So this will undergo Canizaro's reaction in the presence of a strong base, for say concentrated KOH. One molecule will basically I will get the self reduction product, which is your alcohol, and the other molecule will give you the self oxidation product, that is COOH, but since I have base, so this is COO minus K positive. So if you see, I do not have any new carbon-carbon bond, so I think this is the answer only. What's reaction? You know that this is the reaction of alkyl halides and it gives you alkane, so it cannot be the answer because we get alkanes, so there is a carbon-carbon bond. Friedel-Crafts acylation, we have already seen that yes, there is a new carbon-carbon bond. So Canizaro's reaction doesn't result in the formation of a new carbon-carbon bond. Now please, again I am reiterating the fact that these reactions are very important. Please consider these reactions before the NEET exam. Thank you so much. We will meet in the next class with some more important questions. Thank you.